Good morning. Welcome to another session on environmental impact assessment.
So we shall continue with Unit 5, Case Studies. Course outcome, describe the EA for various infrastructural projects. Learning outcome, explain the EA for railway project. Specific outcome, explain the impacts of railway operation on the environment. So we already seen some of the environmental impacts caused due to the operation of the railways and construction of railway tracks. So we will continue from where we left in this session. So next part is the wastewater. The wastewater from plants using acidic cleaning agents, right, or alkaline cleaning agents must be neutralized. Cleaning plants for rolling stock produce wastewater contaminated with oil and grease, and engine oil changes result in waste oil. That is, we are talking about the wastewater that is generated from the plants that are, manufacturing these railway components. So the wastewater can be adequately cleaned at source by simple oil separators. Chemical processing, which also removes emulsions from the wastewater, is complex and expensive. Small quantities of waste oil should be incinerated using a system suitable for small volumes. The composition of the waste oil must be known, and since there is a possibility of dioxin formation, dioxin is a harmful substance that is being generated. When oil separators are installed, it is advisable to use pipe cleaning equipment to keep the outflows of the cleaning troughs clear, since they are prone to blockage. The following safety precautions may be necessary for important groundwater areas. One is diversion of wastewater pipelines out of the more confined protected zone, drainage of wastewater within the protected area through impermeable pipes, impermeable drainage pipes, and fortified trench beds instead of unfortified side trenches. Transfer systems. Railways operate a series of discharge systems for petroleum products which constitute a hazard to water, such as fuel, waste oil, and fuel oil. Transfer takes place, for example, from railway tank wagons to road tankers or fixed position tank farms, and during the fueling of diesel locomotives. The systems are to be planned and operated in such a way that the oils cannot overflow or escape. That is, so that no bodies of water can be contaminated. This is, we are talking about transferring of oil from one railway tank to another tank, or maybe to road tankers, or some other fixed tanks which are located somewhere. Right, you want to transfer the oil from your railway tanker to such tanks. In the first instance, as many transfer points as possible should be combined to form a few centrally located and intensively used facilities. Systems such as these are to be avoided in water conservation areas or headwater regions. Protection of transfer facilities essentially involves paving the surface and drainage with separation. Limit monitors are of course necessary. Full hose dry couplings offer far great protection against losses during transfer. If couplings such as these are used, only a small area at the edge of the track needs to be paved. Weed control. The track bed needs to be kept free of weeds for a number of reasons. That is, to prevent derailment. That is, we are talking about the plants that are growing on the railway track, right? So, depending on the vegetation of the terrain through which the track runs, chemical weed eradication may be possible, though alternative methods such as manual weeding are to be recommended. Right? So, you have to remove those weeds so that they don't cause derailment of the trains. So, in some cases, what happens? A lot of plants are growing around the rails, which can affect the movement of the wheels, right, and finally cause derailment or collapse of the train or the coaches, right. Fecal matter. Lines which carry passenger traffic are subject to contamination with fecal matter. Fecal matter is the fecal matter from the human beings, right. The feces leave the coach through the downpipe and land on the track, right. So you know that people pass urine and stool, right. So the fecal matter passes down from the train, and it is mostly dumped on the railway tracks. So epidemiological research has revealed that UV fraction in sunlight kills microorganisms in a period of 2 to 3 hours. No bacteria will reach the groundwater. At high speeds, it is possible that a pressure wave created by two trains meeting in a tunnel will cause a blowback. New coach designs allow for the feces to be deposited in containers. In any event, orderly disposal is to be ensured. Hazardous goods transport. A basic principle in conveying hazardous goods must be that every substance is handled in accordance with specific rules. Areas affected by this rule are packing, load securing, transportation, packing together with other substances, action in emergencies. Rule books must be adopted covering all substances liable to be transported. It is also recommended that International Uniform Hazardous Goods codes should be used, classified according to the UN numbering system, which describes methods of handling many different substances. The most hazardous types of goods fall in the following categories. One is inflammable liquid substances, toxic substances, corrosive substances, and explosive substances. The substances are to be designated precisely in the waybill, instructions on handling, action in emergencies, etc. for the individual hazard substances should be available in every station and in every locomotive. The weak points in handling hazardous substances on railway occur in the following areas. One is unsuitable packing. Second one is incorrect or absent loading securing, marshalling or reloading. Most accidents occur with very small consignments which do not fulfill the requirements outlined above. Accidents involving tank wagons, etc. are rare. Untrained personnel can also cause such problems and missing documents. Standard equipment for rescue services includes envelope containers, pumping equipment, and tank wagons. The fire service also perform these tasks on the railways as well. Every railway company should employ a hazardous goods officer to whom the regional hazardous goods manager are subordinates. Appropriate training and advanced training must be provided in this area. Noise abatement, that is reduction of noise. So railways generate varying levels of noise, including noise from actual rail traffic and the infrastructures involved in the railway operation, such as marshalling yards, transfer stations for combined load traffic or workshops. Noise emissions depend on the intensity of operation and the location of the railway engineering facilities that are being used. Noise emissions provoke physical and psychological reactions in people, and to that extent, railway noise is considered to be less of a burden than road traffic noise. So, if you are staying, near railway stations or maybe even near railway lines, a lot of noise comes because trains keep going and coming, and it affects the physical and psychological, mindset of people who are staying nearby. Because of their intensive track and ancillary systems, marshalling yards cover the largest area of any train formation facilities. The wide range of operational procedures involved in train shunting, in train formation, and the operations which are ancillary systems involved produce noise emissions of differing levels and the frequency of occurrence. Right? In some cases, there will be shunting. Shunting means changing the engines. So you might have seen in the railway stations, like especially when the trains are traveling a long distance, they change the engine at some particular points. They have some points and fixed points. So every day at that particular point, they will change the engines. Why? Because they need to go again for some more distance. So you cannot have a single engine to travel such a long distance. The active and passive noise abatement measures which can be applied when constructing new marshalling facilities or converting existing ones generally fall into the following individual areas. One is general structural layout of the marshalling yard system, distance from other buildings, rolling stock, organization of operations, and marshalling equipments. The most effective way of improving the noise situation of marshalling yards is through automation. Organizational measures. The measures needed in this context are in particular adequate and comprehensive education and training of people or personnel, cooperation with other transport operators such as harbor companies, airlines, road haulers is recommended. Improving the training and manpower of the operating organization. The creation of a technical and administrative infrastructure, that is disposal and supervision of disposal, monitoring of technical and personnel standards, etc. Deployment of persons with responsibility for problem areas such as hazardous goods. The use of detergents which are environment friendly or which can be satisfactorily disposed of under the local circumstances. Environmental damage can also be successfully avoided by creating an adequately equipped organization responsible for the administration, maintenance, operation, and supervision of environmentally hazardous undertakings, and by strengthening and motivating it to deal with tasks on hand. Emissions from railway vehicles, that is analysis and evaluation of the impacts. Emissions from railway vehicles and systems in operation resulting from design and build quality can be determined from manufacturer specifications or from measurement results. Railway administrations have made numerous attempts to determine the extent of noise from railway traffic and to test the effectiveness of noise reduction measures. Thanks to these experiments, appropriate measures can be taken in future to prevent excessive noise. Hazardous goods regulations should be established for the domestic and international forwarding of hazardous goods, determining which hazardous goods must be conveyed, how they are to be packed and marked, how the vehicles are to be constructed and equipped, and when and how they are inspected, how the vehicles are to be identified, and matters to be taken into account upon loading and unloading as regards loading methods and stowing, as well as the transportation itself. Environmentally correct methods of treating wastewater and solid waste are well known and must be implemented. However, since environmental pollution occurs in railway operation due to ignorance of the consequences, negligent and deliberate actions, supervisory authorities must be enabled and provided with the necessary equipments and measuring devices, right? So, to identify and analyze the environmental impacts, to evaluate them with a view of avoiding them, to ensure adequate monitoring, to implement suitable administrative measures, right, such as fines, orders, prohibitions, criminal prosecutions, right, disposal, organization of proper disposal, right, in an effective manner. So interaction with other sectors, goods are frequently transferred between railways and ships, right? So see the environmental uh, brief uh, on shipping regarding the construction operation of harbors and port installations. So that has to be taken into account. Some parts of the road transport and inland waterway systems have similar problems such as railways, particularly in the area of vehicle and ship maintenance. In this regard, we need to refer to the briefs on water disposal, that is wastewater disposal, solid waste disposal, and disposal of other hazardous waste. Meaning what we are saying, basically saying here is that although we are actually dealing only with railways and expressing everything with respect to railway officers and railway systems and the railway administrations, they need to know something about ship maintenance and what kind of accidents can happen there, so that the railways don't cause any impact on the water bodies, right, such as the oceans. The railway sector, being primarily devoted to the transport of passengers and goods, also ties with the environmental briefs on spatial and regional planning and transport and traffic planning. So, coming to the summary, railway lines intersect landscapes and regions, but thoughtful planning and execution will elevate or remove these partitioning effects. Electric trains do not themselves cause any air pollution, while diesel engines can cause pollution. Railway traffic noise is less than road noise and is felt to be less unpleasant. Railway lines should be routed out of the way of settled areas. In densely populated areas and where trains travel at high speeds, noise abatement measures should be provided. International standards should be used as the basis for the regulations on the construction, safety of railway vehicles and handling facilities. This will lead to the use of railway equipments, generally enabling safe and environmental friendly transportation on the basis of an appropriately planned executed network infrastructure. In certain areas, it may, however, be necessary to impose construction measures which go beyond these rules or deviate from them in order to take into account of the particular local conditions. Further requirement is that the people and the controlling and supervising authorities and operating organizations should be fully aware of the potential environmental effects, risks, and preventive measures. They should have appropriate training and receive institutional support in carrying out their tasks. To this end, the training courses, the resources for performing monitoring and supervision tasks, and financing must be available in good time. An environmentally acceptable railway system can only be created with safe, state-of-art transport equipments, equally safe operation by trained people, an institutionally strong operating organization to maintain the rolling stock and systems, to control the traffic operations, and to inspect and monitor the effect on the environment with close harmony between these three areas. Thank you.
Thus, we come to the end of this session. Thank you for your participation. Looking forward to meeting you in the next session.